Assalamu alaikum. In the previous video, we have discussed about the gross error and random error. In this video, we'll discuss systematic error. Error that occurs due to a system and follows a certain pattern is referred as systematic error. It also occurs due to a problem that continues throughout the experiment or measurement. It is classified into 5. We'll discuss about all these 5 types of systematic error one by one. Now before going ahead, let me give the definition. Let me write the definition of systematic error on board. Error that occurs due to a system and follows certain pattern is referred as systematic error. Okay. Now, as I told you, it is classified into 5, or we can say systematic error occurs due to 5 reasons that we'll discuss one by one. First, I'll start with the instrumental error. Instrumental error. As the name denotes, this kind of error occurs due to a faulty instrument. Suppose there is an instrument which is not calibrated properly at the time of manufacturing. If we use this kind of instrument, then it may result in some error, and this error will continue every time we perform some experiment using it. Okay, so here error that occurs due to an instrument which is not calibrated properly. Now, what is this calibration? Calibration is the act of marking an instrument. For example, I have a meter scale. In lab, we use a meter scale to measure the length. Suppose this is a meter scale. Now, usually a meter scale is of 1 meter in length. The distance between two edges of a meter scale is nothing but 1 meter. So here in calibration, what is done? The point between the edges are divided into 100 equal points. Okay, so if you select any 2 points, any 2 consecutive points, the distance between them will be equal to 1 centimeter. So it will have 100 points, that is equal to 1 meter. Okay, so we know the total length of the meter scale is 100 centimeters, then it represents a 1 meter. Okay, this how this division or a marking of an instrument is referred as calibration. Suppose if 1 or 2 points, the distance between 1 or 2 points is not equal to 1 meter, 1 centimeter, means such scale is not calibrated properly. If you use such scale for any experiment, then it will result in instrumental error. Okay, so here the cause or source of this kind of error is the faulty calibration. No, let me write this. Sources, measurement using a faulty calibrated instrument. Okay. Now, let me give an example for this. Suppose you carry out one experiment and you want to measure the length of some object. For that, use a meter scale whose edges are worn out. In such case, if you take the measurement, then it will come along with some sort of error, referred as the instrumental error. Clear? So, how this kind of errors can be avoided? Correction here. How we can correct this kind of error? This kind of errors can be corrected by using an instrument which is free from any kind of faults, or by the careful selection of an instrument, this kind of error can be avoided. Okay, careful selection of equipments can reduce this error. Right? Let me write the example here. Using a meter scale whose edges are worn out. Okay, that's all about the instrumental errors. Now we'll go ahead. We'll discuss about another type of error which causes systematic error. The second is imperfections. Imperfection in experimental technique or procedure. Now, as the name denote, here the limitations in the experimental setup usually cause this kind of error. Now, for example, if you use a calorimeter, which is not surrounded, or which is not covered by a proper insulation. In such case, the heat will start losing to the surrounding. So this kind of error can be avoided if we replace the equipment with a good one. Clear? So the correction is very simple here. What we need to do? We need to change the equipment with a better one, as we did with the earlier case. Now third is a personal error. Personal error. No, it is quite common. Already about this we have studied in a gross error. Now the errors which occur due to the person who performs the experiment. This may be due to some personal traits or the carelessness of the person who performs the experiment, or sometimes while taking a reading we mention wrong values in the calculation. That also results in this kind of personal errors. So what is the solution for this? How one can avoid personal error? Personal errors can be avoided only if the person who performs the experiment is careful and sincere in his approach. Clear? This is called it as personal error. Now next, the errors due to external cause. Errors due to external causes. Errors due to external causes. What are these external causes? Sometimes when we perform the experiment, sudden change in the temperature, humidity, or fluctuation in the voltage may cause some sort of error. Now, uh, this kind of error cannot be avoided that easily. Or we can say it is impossible to avoid the errors due to external causes. Okay? Because who knows? Now, suppose if we start an experiment in between, if the temperature drops, we cannot able to rectify the temperature. In the similar way, if there is a fluctuation occur in the voltage while performing any experiment relevant to electricity or electronics, even in such case, the errors may occur, and it cannot be avoided that easily. And the last one, the fifth type of error, which causes a systematic error, is nothing but least count error. Least count error. Now, before going ahead, let me tell you what is this least count. Least count is nothing but the smallest value that can be measured with the help of an instrument used for the measurement. Okay, let me write this on board. Least count. In a short form, it is represented as LC. It is nothing but the smallest value that can be measured. The smallest value that can be measured. Using an instrument. For example, with the help of meter scale, one can able to measure the smallest length to be equal to 1 millimeter. It is not possible to measure a length less than 1 millimeter because 1 millimeter is the least count of meter scale. So in such case, suppose you want to measure the diameter of a small metal rod. In such case, if you use meter scale, the value or the result that you obtain will have some sort of error. In such case, if you replace meter scale with screw gauge, then you may get a better result, because the least count of screw gauge is nothing but 0.01 millimeter. Compared to 1 millimeter, it is really a better value. So the error that occurs due to least count of an instrument is referred as the least count error. This can be avoided by using an instrument whose precision is better than the instrument which was used earlier. I hope the video is useful. If you have any kind of doubt relevant to the topic, kindly put a question in the comment section. Thanks for watching.